Assalamualaikum warahmatullahi wabarakatuh, and a very good evening. I'm with Dr. Abdul Halim and Abdul Latiff, our Seismic Data Processing lecturer. So, today I will talk about technical review presentation about swellness attenuation by myself, which is Ahmad Fahmi Afiq, Muhammad 25127. A little bit of my presentation today is about swellness attenuation. Noise attenuation by machine learning technology has achieved considerable success in the area of the computer vision. Later in this presentation, I will explain more how to overcome swellness attenuation. Since then, wave that occurs by the swellness is considered as a big obstacle to seismic exploration in the marine world. Okay, so what is swell noise? Swell noise is any recorded energy that interferes with the desired signal can be considered as noise. However, efficient attenuation and removal of noise is necessary for high quality imaging. A swellness is induced by a long-term shift in the surface, and it is form of inconsistent noise characterized by low frequency and high amplitude characteristic. It is typically the first step in the processing of many seismic data, which is to remove the swell noise. It is produced by the high amplitude with certain range between 2 until 10 Hz, and sometimes induce delay or temporary suspension of data acquisition in marine survey. So there are four objectives in this paper review. First, to overcome the seismic noise by applying time frequency denoising on slowness gathered by the new approach. Second is the innovative approach on the automation of the noise detection step to attenuate swell noise. Third is to diminishing the marine swell noise by stacking in the wavelet packet domain. And last but not least, to improvise low seismic data quality after filter application into high seismic data quality. For the literature review, we divide into 5 chapters. First, main people working in the area. Second is the recent major advances and discoveries. Third is the significant gaps in the research. Fourth is the current debates, and lastly, idea where the research might go next. For the main people working area, the Airbus said that swell noise is the most dominant noise type on the raw marine short gathers and mainly originate from the raw sea state due to the weather condition, which produced by the wind-driven longitudinal sea surface wave and can be regarded as incoherent noise in the seismic datasets. It's suggested two important keys, which is the hydrostatic pressure fluctuation due to the vertical motion of the ocean because of the weather condition, and another one is the dynamic pressure variation along the streamer due to turbulent layers surrounding the streamer. The Peacock in 1983 said that there are two different mechanisms that create swell noise. On the fluid field streamer, the streamer motion can induce transversal waves that we call the buzz wave. You must state that most of the methods developed to attenuate high amplitude swell noise are based on the rejection of low frequency band on the recorded data. For example, suppressing the amplitude at 0 until 15 Hz frequency band. Bach and Deckers in 1993, Hannan and Morrison 2002, and Snarkis at 2004 stated that there is also a second swell noise producing mechanism apparent that waves can induce a cross flow over the streamer, which the cross flow can also be induced by the ocean currents. Now we proceed to recent major advances and discoveries. In this chapter, we explore there are three recent major advances and discovery, and we talk about the first one is the conventional method. The conventional method is which the swell noise cannot be removed by the band pass filter without also removing large part of the seismic reflection signal. Instead, we have found that time frequency filtering by the Elbows and Baccarat stated that it works by computing spectral estimate at each frequency. Later compared with the amplitude, the estimated of presumed of good trace a chosen window. If the amplitude larger, then it will be attenuated to the level of the presumed good trace. Then it will be repeated for all frequencies specified by user and change back to time domain for each sliding window. In order to get the optimal result, it is important that size of the window is not too large. Next is the continuous wavelet transform. In this chapter, they design filters that can attenuate coherent low frequency noise such as swell noise without affecting parts of the data needed by the evaluation schemes. In this work, we propose the use of the continuous wavelet transform (CWT) to achieve efficient localized frequency band filtering for the swell noise attenuation. By constructing filters based on the wavelet transform for suitable set of wavelets and scales. Next, we apply the CWT to the seismogram, which means convolving each trace with the wavelet in many scales. This operation increases the dimensionality of the datasets as each seismic trace is now represented as a two-dimensional panel, which allows us to produce CWT panels representing our ideal output and then create masks in the CWT domain to filter an undesired event in the real datasets. We proceed to the third chapter in the recent major advance and discovery, which is the automatic swell noise attenuation process, which it is deriving a global function fx signal mask for each gather, which finding traces are contaminated with swell noise and which frequency in those contaminated traces the noise is present. The noise detection is done globally. It is disjoint from the noise filtering step, so there is no trade-off in terms of the finding good parameterization. The possibility to adapt the special window size for the filtering as function of the frequency for a better signal interpolation. The derivation of the signal mask is done over a portion of the seismic gather, where the signal to swell noise level is low. So in this chapter, I found 4 significant gaps in the research, and I will explain first about the stacking in the wavelet packet domain in 1999. So the stack data in the wavelet packet domain after removing wavelet coefficient that contribute a low coherency in the wavelet packet domain, which the wavelet packet domain is localized in both frequency and time. It may target simultaneously those frequencies and those time at which the noise exists. The number of data samples in the problem areas is reduced and processing time may be optimized by the judicious selection of the wavelet packet decomposition. Because the wavelet packet transform is not shift invariant, we must carry out the processing on CDP gathers that are corrected for NMO. Future work should be concentrate on understanding the complete implication of a time shift in the wavelet packet domain and incorporating this in the algorithm, which is to produce a high quality image but must be deleterious effects on the information content of seismic attributes. Next is the swell noise suppression by Werner accreditation filter, produced in 2011. The Werner predation filter method can be considered as an alternative method to the conventional band pass filter in removing the swell noise. The applications show that the method removes most of the swell noise from the raw seismic data, trying to preserve the deeper reflection amplitude, enhancing the available frequency band. When compared to the conventional band pass filter result, in the final migration section obtained by the Werner prediction filter application, the deeper reflections have higher amplitudes and then shows better lateral continuity, suggests that the method can also be used to remove other coherent noise types, providing that an appropriate noise model can be determined. We continue to the swell noise attenuation, a deep learning approach in 2019, which is the one of the latest paper that I have found. Specifically focusing on the swell noise attenuation, a straightforward approach is to apply FX filtering to the frequency range where the noise is present and replace noise traces with the FX filtered region for these frequencies. Rabi 2005, Jane and Sung 2019, J 2012 stated that deep learning in the denoising tasks for images have been developed in the past decades. Many research work indicate that they have made a giant leap in this field. Bekra and Van der Weyde 2010 stated that they have developed an automatic method to exploit differences in statistical properties between the swell noise and signal amplitudes to construct a detection criterion. So in the current debates, I divide into three sections, which by Elbows in 2009, Watts in 1999, and Zhao in 2019. Watts in 1999 stated that shows how wavelet packet domain processing could reduce wave swell noise in varying data. After eliminating wavelet coefficient that lead to low coherency in the wavelet packet domain, they stack data in the wavelet packet domain. The benefit of processing in the wavelet packet domain is that it can target both the frequencies and the times when the noise is present. And both in 2009 stated that in the article it has shown how times frequency denoising can be used to reduce many of the most common type of noise found in the marine seismic. The general idea is to turn each type of noise into domain where it somehow stands out and then attenuate it. Zhao in 2019 said that it proposed a deep learning model for seismic swell noise attenuation. They use only two noise, which is the application applied to a synthetic data sets and a field dataset. When opposed to traditional methods, it yields outcomes that are extremely comparable. The only two noise easily and greatly improves raw data quality with simple uplifts. The model indicates that swell noise has been effectively detected and eliminated with mild primary hertz based on the true and careful analysis of the frequency panels, typically channels, and stacking performance. So in the last chapter of the literature review, the ideas where research might go next, I divide into three sections also. It is by the Tamu-Nabereton, Amekiri and Gary in 2015, Alves in 2019, and Dondurur and Kasli in 2012. Tamu-Nabereton, Amekiri and Gary in 2015 state that the work has shown that the use of the time frequency algorithm is an effective tool suited to the attenuating variety of noise energy from the seismic gathers from the marine environment, and swell noise complexity can be solved. It affirms the reliability of the approach and the validity of the outcomes. Albers in 2019 said that a workflow for creating and applying a filter for coherent noise using the continuous wavelet transform. And it shows that this method can efficiently attenuate swell noise present in the data without the need for the low-cut frequency filter in the Fourier space, which could affect the low frequencies of the useful data. The Dondurur and Kasli in 2012 stated that the winner pass filter method can be considered as an alternative method to the conventional band pass filtering in removing the swell noise. The applications show that the method removes most of the swell noise from the raw seismic data, trying to preserve the deeper reflection amplitude. So from the current issues, I summarize from the paper of Toward and Automatic Swell Noise Attenuation by Bekra M 2014 stated that often due to the complexity and the intensity of the swell noise, The filtering solution is applied in cascade several times, both in the short and in the channel domain to achieve the desired results. In the context of onboard processing, where time and resources are constrained, this proves to be challenging because there is need of extensive testing due to multiple passes. There is also a need to restart the testing cycle whenever swellness characteristics vary significantly with the change in the weather condition. The reason for that is the potential risk of the signal distortion because source separation is often formulated as a DNS problem in the domains different from the short domain. For the above reasons, one can appreciate that the need for a robust swellness attenuation solution that works only in the short domain and in a data-driven way to correct and for the variation of swellness characteristics. Another summarized from the deep learning approach by Zhao 2019, direct applying this method to the seismic data was not effective since the evaluation criteria from the geophysical domains require a high-quality visualized image and the ability to maintain original seismic signals from the contaminated wavelengths. There is an approach equipped with a specially designed deep learning model that can effectively attenuate the swellness with the different intensities and characteristics from the short gathers with the relatively simple workflow applicable to marine seismic datasets. The proposed deep learning-based approach can be considered as an alternative approach that combines and takes advantage of both unconventional and data-driven methods to better serve swellness attenuation. Such a swellness model can be derived from any marine data by using a conventional algorithm, effectively and efficiently training on even a contaminated swellness model guarantees an improved performance of attenuating swellness from raw data. In combination with conventional and data-driven algorithms, it would introduce a new means with strong potential to solve attenuation tasks relevant to swellness as well as other coherent noise. As for the conclusion, the noise of the seismic data is necessary in order to obtain good quality of the seismic parts. This denoising mixture was primarily used to target low frequency swell noise with abnormally high amplitude but also random noise. Effective and efficient training on the polluted swell noise model will ensure an improved output of attenuating swell noise from raw data. This approach, in combination with a traditional and data-driven algorithm, will introduce new means with a strong potential to solve attenuation tasks related to swell noise as well as other coherent noise. This is the reference, and I think that's all from me. Thank you.